All right, sorry for the interruption there. Okay, so, all right, we're going back to talk about this altitude, this orange altitude drawn in. Here's the whole thing is my hypotenuse. But this altitude now divides this hypotenuse up into two pieces. Okay, it divides this up into the long piece that goes from A to D, and the shorter piece that goes to D to B. So it divides it up into those two pieces. What's interesting is the length of this altitude. The length of my altitude from C to D is the geometric mean between these two pieces. So we can use this to help us find either one of the two pieces of the hypotenuse or the altitude. So that altitude, how we would set this up is the altitude, we'd set up our proportion. The altitude is the mean. The length of the altitude is the geometric mean. So that altitude is C to D. That goes in the mean spot, C to D. Okay, and the two pieces of the hypotenuse go in the extremes. So A to D would go where one extreme goes, and D to B would go where the other extreme goes. Okay, so C to D, again, the altitude is the mean. Okay, so another way to write this to help us remember it, the altitude goes here, and this would be piece of hypotenuse, piece of hypotenuse, piece of hypotenuse. One piece, the other piece. One hypotenuse piece and the other hypotenuse piece. But again, the altitude is that mean. Okay. So we can actually use that to help us find missing pieces. For example, here in example 4, so we're not going to look at this one yet. Okay. So again, this is the geometric mean altitude theorem. Okay. So here we have an altitude drawn in, example 4, part A. We have this altitude drawn in. And it divides my hypotenuse up into two pieces. We have a piece of 10 and a piece of 4. So my first is to set up my proportion, and I start by just drawing an empty proportion. Ratio equals ratio. Okay, the altitude is the mean. The altitude is the mean, so the altitude is going to go in the mean spot. The 10 and the 4 are going to go in the extreme spots. Doesn't matter which way you put them, 4, 10, 10, 4. Okay, and now we just multiply means at extremes. Multiply the 10 and the 4, we get 40. X times x is x to the second. Well, if x to the second is 40, then x would be the square root of 40. Okay, the square root of 40, well, 4 can be split up into 4 and 10. The square root of 4 is 2, so square root of 4 is square root of 10. So we have 2 root 10. So the length of this altitude is 2 square root of 10. Okay, that's using the geometric mean altitude theorem because it helps us find the lengths of the altitudes. Okay. We also have a geometric mean leg theorem. Again, in a right triangle, the altitude, again we have that altitude drawn in, from the right angle to the hypotenuse, again divides the hypotenuse up into these two segments. So again, this whole thing is the whole hypotenuse, okay, but it divides it up into two pieces. Okay, the length of each leg of the right triangle, so each of these legs, here's one leg, here's the other, okay? The length of each leg of a right triangle is the geometric mean of the lengths of the hypotenuse, the whole hypotenuse, and the segment of the hypotenuse that's adjacent to the leg. So if I'm looking at this leg AC, so again, set up my proportion here. AC, that's a leg, well, let's label leg and leg, is the geometric mean between the whole hypotenuse, AB, again, that's a whole hypotenuse, and the piece of the hypotenuse that's by that leg. So the piece of the hypotenuse that's by this leg is A to D. So piece closest. Okay. So I can set up this proportion, AB over AC equals AC over AD, again, because this leg is a geometric mean, or I could do it with the other leg. So use other leg. Other leg's BC. Again, BC is the mean. And then of the whole hypotenuse, which is AB, to the piece that's by it, DB. Again, these are both legs, leg, leg. This guy and this guy are both legs. This is the whole hypotenuse, and this is the piece of hypotenuse. The piece of the hypotenuse that's closest to that leg. Okay. So here, in example 4, okay, we have here, it helps, sometimes helpful to label, this is a leg, this is a leg, this whole thing is the hypotenuse, okay, that whole thing. Okay, so the leg is the geometric mean. So that leg, again, set up my proportion. The leg is the geometric mean. So my leg is going to go there, y and y, between the whole hypotenuse, which the whole hypotenuse is 8 plus 3. 9, 10. The whole hypotenuse is 11. Okay, between the whole hypotenuse, which is 11, and this piece right by it, which is 3. Okay, I wouldn't use the leg, I wouldn't use the 8 here because the 8 isn't the piece of the hypotenuse that's by that leg. And then now we just means extremes. 11 times 3 is 33. Y times y is y to the second. So if y to the second is 33, y is equal to the square root of 33, which I don't think that simplifies, so y is just the square root of 33. All right, we're just going to do one more example. We're not going to do extra example 5. We'll just do example 5 here. Okay. To find the cost of installing a rock wall in your school gymnasium, you need to find the height of the gym wall. So we're looking for this total height. Use a cardboard square. See this cardboard square here? Okay. To line up the top and bottom of the gym wall. So you've lined it up to the top, lined it up to the bottom. So basically what we've created is a 90-degree triangle, a right triangle. Your friend measures the vertical distance from the ground to your eye. So from the ground to this eye, this vertical distance is 5. And the horizontal distance from you to the gym wall, this is 8.5. So it might be helpful here to label. This guy right here is a leg. This guy right here is a leg. This whole thing is the hypotenuse. This guy right here, this 8.5, is an altitude. So here we have an altitude, and we want to know this whole piece. So I'm thinking we're going to need the geometric mean altitude theorem, because I know the altitude is the geometric mean between the two pieces of the hypotenuse. So here this altitude, the altitude, which is 8.5, is the geometric mean between the two pieces of the hypotenuse. And the two pieces of the hypotenuse, one of them is W, the other one is 5. So now I just means extremes. 5W 8.5 times 8.5, which gives me 72.25. Divide both sides by the 5. And W equals 14.45. Okay, so that's from here to here. We want to know the height of the whole wall. So we'll have to add that last 5 on, which gives me 19.45. And we're in feet. So the height of the entire wall is 19.45 feet. Okay, again, we're not going to do extra example 5, but I want you to go ahead and jot down your practice down here. If you need help or have questions, please come see me, and good luck.